Hey guys, this is Joel, and telling about myself, I'm a computer science graduate. I just graduated this year, and I do kind of specialize in machine learning. And you might be asking, then what are you doing here? Hmm. But I thought I got some time, so I thought maybe I'll just hone up some skills. And with that, I was like searching what to do, and then I got onto this awesome thing called learn in public. So I'll be learning stuffs daily, obviously. And then I will be uploading the videos which in which I'll be teaching you what I learned. So that it will be like I'll be teaching you what I learned and you will be learning more with me. So you'll be learning with me. And also you're open to give me advice or any criticism. Like what do you want to say? Like to improve me. So I'm open to it. So let's learn together. And the purpose of this video is that I don't mean the purpose. The content of this first video is like we'll be learning machine learning through TensorFlow. So we'll be using the TensorFlow to do the machine learning. So I won't be covering the theoretical part much since I'm well aware of the theoretical part. So I thought I will be covering the practical part, like the coding part. So we'll be using the TensorFlow to do it. And yeah, we'll start with the neural network. So yeah, so let's start with the neural network. And yeah, first of all, I'll say what neural networks. Neural network is like uh, many layers of neurons. So it is those neurons are similar to the human neurons, so they connect and they give signals. So first, let me tell you that the neurons have three layers: the hidden layer. The input layer, the hidden layer, and the output layer. So in that, so in the hidden layer, we'll be having nodes. So basically, these nodes represent uh, the features of an input data. So for example, if you're sending an input, for example, an image, and the image has 64 pixels, so each pixel will consider as an one input feature. So these input nodes would be 64 in that case. So for this architectural diagram, I'm going to put T. And the output also has the nodes, so which represents the output. So for example, if you're going to represent that are going to be like three classes that you're going to find. For example, you're going to predict whether it's a cat, whether it's a dog, or it's an, what can we say, a bird. I mean, peacock, right? So then you'll be having three nodes. So each node representing each class. So cat, a dog, and a peacock. So doesn't that sound awesome? And also, when you have this output layer, they will be in a probabilistic distribution form, which means when you add the values of these blocks, it it will add up to one. So, for example, the for an image, so it could be a 0.5, it could be 0.3, it could be 0.2, which adds up to one. And what it basically does is that, so since for an input image A, we have in zero point 0.5, 0.3, and 0. So which means it is highly probable that it's gonna be a cat. It might sound confusing, but yeah, we'll get on to it. We'll get a grasp into it, right? So might be a cat. So this is how it works. So yeah, so these are the nodes. So and here it is like in black box. So do you know black box? So it is similar to black box. We don't know how it happens, how it works. It is like a function. It is like all the mathematical part happens over the hidden layer. So yeah, let's get in. So the input layer will be connected to the hidden layer like this. So and yeah, it can be connected in ways like we have to decide it. And if every layer of an current layer is connected to every layer of the previous layer, it is called densely connected layer. So yeah, it is a densely connected layer, and it is the same over here too. So yeah, let's just keep it that it is densely connected layer. So it is how it works. It is an input layer. There is an input layer, and it goes to the hidden layer. So all the magic happens here, and then it goes to the output layer, giving us the output. right? So, and another thing is that we'll be using an activation layer, and after that, some optimizers to optimize the output. And yeah, and you also learn about the weights and biases. So, first, I will tell you the difference between the bias and an input. So, the bias will be connected to the nodes, and this bias helps to, tamper doesn't mean tamper. So it helps us to alterate the weights and that it helps us to alterate the neuron nodes in such a way that it is decidable for us. So if we need to increase something, we'll do something with the bias so that it will increase. So this is how it works. So I pretty much hope I've covered the neural network thing. So if you ask about the activation layer, so so as I said, I'm not gonna like anyway, so like I said earlier, like if you want me to cover about the activation layer, so activation layer kind of does some things which I will be describing later, which I will be telling later. So before that, I will continue with this thing with machine learning using TensorFlow. So yeah, first of all, I'm gonna create a new file. So like so let's just keep the name as sample neural network dot ipynb. So I'm using this thing and let me just do yeah. So first, what I want to do is that sorry for this thing. Yeah. So first, what I'm gonna do is that I'm gonna import these libraries. So for those guys who are wondering what is this libraries, and if you're having some error, you need to pip install this TensorFlow and NumPy, and after that you are good to go. Thumbs up. And yeah, so we'll be importing TensorFlow, TF, and for Keras, and then you will be importing NumPy, and then Matplotlib to plot the thing. And yeah, so first of all, I'll be teaching you line by line. So it is in code which I already went through, and I have to give a shout out that I have to acknowledge that I'm learning through the free code camp. So these are the code which they have given. So I learned through these code, and I'm teaching you these code. So this is not created by me. So first of all, let's just say um train image. So what I'm gonna do is so this code basically what it does is like it is gonna predict what cloth it is. So it is for this we are gonna take a data set. So it is a data set from Keras. So they already have this fashion MNIST data set which you can see over here. So I'm gonna use that data set load into our model to predict uh what cloth is it. So we will get into what I'm doing. Right now it might be confusing and all. Anyway, okay. Uh, uh, so what I'm gonna do is that I'm gonna get the fashion MNIS data set from Keras.datasets, and I'm gonna load the data like in this format: train images and train labels, and test images and test images. With this code, I'm gonna get all the train images, the images which I will be with which I'll be training, and its respective labels, and here are the test images and its respective labels. And over here, so these are the class names. So in this data set, in the Google, if you check out this data set, they have this nine classes. I'm sorry, 10 classes: t-shirt, trouser, pullover, dress, coat, sandals, shirt, sneakers, bag, and ankle boot. So they have these 10 types of dress in that data set. So in this data set, they'll be containing these 10. And yeah, so these are to name the classes. We have to define the class before training and model. So I did this, and after that we are processing the image. So we are basically making the image to have the values between 0 to 256. I'm sorry, 0 to 255. So we are doing this. We are pausing the image, and after that, so I'll just run you the code. So I've imported the code, so which might take uh, 10 seconds around, depending upon your computer, and then run this code too. Okay. So let's read the neural network. So what I have been doing till now is like I imported the I'll just say wait, why did this? So I've been importing the libraries and then I've been laying the foundation of the data set. So I loaded the data set and then I have described the classes and then I have processed the images. Like I have decreased like 256, 0 to 256, right? And now we are going to define the neural network. So for this, we have to write the code, like define a variable, keras, and that sequential. We are defining a model right now. So for that, for the first layer, keras.layers dot flatten. So flatten is like a function which makes all the values to convert into an single dimension, right? So in a similar dimension. For this, we are going to flatten the input shape into 28 into 28. So the all input images will be flattened accordingly. And then here keras dot layer dot dense, which means it is going to be densely layered. So and here the number of nodes is 128 and the activation layer is nil function. So before going to that, so I'll just explain how ReLU layer works. Hold on a second. One sec. So ReLU layer is like X axis, Y axis. No man. I'm gonna use it. Yeah. So what it basically does is that all the negative values will be made to zero and all the positive values will be the same. So it eliminates the negative value. So it is what the ReLU function does. So we are going to use the ReLU function over there. There are lots of activation functions like ReLU, leaky ReLU. So usually, the number of nodes in the input layer, like which is 128 over here, will be lesser than the number of nodes in the input layer. So which is not a necessary thing, but here I do use it, and normally people do use it. So it might change. It will change the result depending upon that. So normally it is practiced to keep lower than the input layer. So after that, this code will run with this thing, right? I wanna run it, right? Yeah, we are on the but we're gonna use an optimizer over here so that we can increase the accuracy. So model.compile optimizer just Adam. So we are gonna use the Adam optimizer. It is one of the optimizer and loss and then metrics. So with this optimizer, we will be focusing on increasing the accuracy. So, yeah. So actually, what we are doing is that we are tuning the parameters. So these are called the hyperparameters, and we are tuning it. So we are changing these hyperparameters like ReLU, softmax to increase the accuracy of the model. So it is called that. So after doing this, you will be fitting the model, right? So here we will be fitting the model with the train image and then with its respective labels, and we'll be having 10 epochs. So for those who don't know what epoch means, so epoch what basically does, it will be running a loop. So for over here, I will be looping 10 times for the model to train. So yeah, so this will take some time. So yeah, I run with the Seret, so which means I have to do this again. So I have to compile and then use the model of it. So I hope this works now. So depending upon the computer or performance of the PC, it might change. So this time I'm gonna say that I'm using Visual Studio Code and I already created a virtual environment to do this. So yeah, I'm pretty much covered all those parts. And I've already done this code, so basically it's supposed to run. I don't know why it didn't run, but yeah, let's just wait a few more seconds. So it takes approximately seconds for each thing to go. So let it, and after that we'll be doing this. So yeah, we have successfully trained the model, uh, the neural network to predict the cloth as in which fashion it is. So yeah, now after training the model, we are evaluating the model. So for this, we are going to use the model.evaluate for the test images, the test labels, and the verbose equal to 1. So for those who don't know what verbose means, so it basically gives the information like uh, when you are training a model, for example, if you train the model, there are lots of information. So if we increase or decrease the verbose, so it will affect the how much information it is visible to you. The more information you will be seeing, the less information you will be seeing. So here I have set the verbose to 1, and yeah, so basically with this evaluate, I will be getting that loss and the accuracy. So yeah. So how much data is lost on the accuracy of the model. So with over here, we are getting the accuracy of 88.12, which is good, right? And and you have to know this. The model accuracy of this neural network is 0.9112. And when we do the evaluation, it's 0.881. So what does it mean? Is that the difference between that accuracy of the training and the evaluation part is called the overfitting part. So you know overfitting. So when for example, I will explain the overfitting. So you have a bowl, and if you fill the bowl with the enough water, and then if you continue to pour more water, it will fill. It will just spill out of the bowl, right? So it is what overfitting means. So is to decrease this overfitting part, we can decrease the epochs actually. So for example, I wanna decrease the epoch now. It might change. So I wanna try with this. So I've done one epoch. So the accuracy is 0.91. And over here, I wanna do this, I run this again. And see, we have increased the test accuracy now. So yeah, like well during this fine tuning various hyperparameters, we can change that. And normally, what people tend to do is that they will have this epoch to hundreds, thousands, thinking that the more epoch they have, the more better. But it's not the case actually, because like it would find the same data. So it will repeat again and again. So the overfitting becomes an issue over there. So we have to find perfect spot where we have to stop the event. So anyway, and after that, I'm gonna go with we have actually tested the accuracy validation part, and after that, we're gonna predict the model. All right. So we are gonna predict the model. So over here it is the prediction part. So already we have defined a variable predictions. So model dot predict. So it is an inbuilt function. We predict the test images. So we will be predicting all the test images, right? And it will be stored in the predictions. So and then for example, uh, I will comment this part. So let's just predict the first in. Okay. So for an array, zero is the first part. So these values indicate the probability of that input being an the respective class. So for the input 0 for the first input, it the probability of being it to be the first class is 5.2. So it shows these values, right? So what I'm gonna do is that I'm gonna use the magical function called np dot organize. All right. So when you do it, so we'll get the highest value, which means it belongs to the ninth class. So let's just say what is the ninth class. So to do that, what I did. is classmates. So if you look over here, it is the class name 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it belongs to the ankle board. The first image belongs to the ankle board. So it is what it has been predicted. So if I use the class name, it's gonna be this because sorry about that. I'm sorry. And after that, uh, I will show you the image. So this is where we'll be using matplotlib for plotting the library. So using this, we'll be plotting the image. So let's just find the first image. So this is the first image. So it is on boot. We have predicted it to be what ankle boot. So we have successfully predicted it to be ankle boot. And yeah, so yeah, this is what the code does. So if we change, for example, if I change, actually with this I have predicted all the test images. So for instance, if I change the fifth image, I mean the sixth image in the data set, and then go it, so it is in thousand. So if I change over here, it is in thousand. So we have predicted it right. So we have successfully done neural networks through TensorFlow. And yeah, actually, I have made a script to check whether the expected output is similar to the predicted output. So I'll just run this code, right? So you can just see through this code. It is in Python script which I have made to check whether the predicted output is similar to the expected output. So yeah, okay, run this code, and then I have put the hundredth image. So yeah, so the image is often dressed. So it is expected to be dressed, and I have guessed it that the model has predicted it to be in dress. So yeah, we have successfully completed neural networks through TensorFlow. Thank you.